Okay, so first thing we're going to talk about today. What is trigonometry? What do you think that is? No one talks because we know it's recorded. So I'll tell you. Trigonometry is the study of triangles. What kind of triangle do we have right here? A right triangle. Good job answering. Okay, so in this right triangle, what is that little boxy dude?
90 degrees.
He's 90 degrees. He is the right angle. That means angle if you forgot from geometry. Are we good so far? What is that other pink box across from the right angle? That is called your hypotenuse. So in trig or in right triangle studies, you need to know the hypotenuse. You also need to know these weird, crazy words, sine, cosine, and tangent. If you say sin, cos, tan, I might make fun of you. Okay, in your brain, totally, go for it. Say sin, cos, tan, that's fine. When you speak out loud and you answer a question, this is technically sine, cosine, and tangent. Those things should look familiar from this guy right here. Have you seen this before? So, ka, to, from geometry. I used to tell my geometry students that there was a group of Native Americans and they were trying to like find the angle of the sun. So they were chanting like around the fire, like so ka toa, and that's where it came from. That's not really where it came from, but that's where I'm going to say it came from. So this is the most important thing in your life right now. So you write this at the top of your paper. I leave it here because it's already written here. I'm not going to write it again. So sine of theta, by the way, that's what this is. Theta is just an angle. We in math use a lot of Greek letters. This one is used the most. It is theta. It will also help you if you, when you go to college, you'll know like a couple Greek letters for like fraternities and sororities and stuff. So that's good too. So sine of theta is technically called what? I need words. What is the fraction that goes with it? What's the first word for O? Opposite. Over. Good. I'm also really lazy, so I'll probably just write OPP period, HYP period. That's fine too. Cosine of theta is what? What are my words? Adjacent, very good, over what? Hypotenuse. And then lastly, tangent of theta is TOA. So what is that? Opposite over adjacent. Good. Now, these scary abbreviations over here are things you probably have never seen before. So this is the first new thing I'm going to teach you. CSC stands for cosecant. Cosecant is paired with sine. They are brothers, okay? They are very, very similar. You know how siblings kind of look the same, but not exactly the same? They are very similar, but they are reciprocals of each other. What does reciprocal mean? Flipped, opposite. So cosecant of theta is technically 1 over sine of theta. That is the last time I'm ever going to write that because it doesn't make sense to me. Okay, sine of theta is a fraction. Why would I put fraction and fraction together? Okay, so technically the definition is 1 over sine of theta, but really all we're doing is flipping this. So cosecant isn't O over H, it's H over O. So hypotenuse over opposite. And then this next word is not a college football division. It is secant. Okay, secant is brothers with cosine. They are very similar, but secant is technically 1 over cosine of theta. But cosine is A over H. So what is secant? H over A, hypotenuse over adjacent. So the way that I remember that is math never makes sense. They always try to make it harder than it should be. Okay, so sine, it would make way too much sense for the S words to go together. They don't. Okay, so sine always goes with cosecant, the C word. And then cosine goes with secant. So they are switched, SC, CS. And then the last one is a little bit easier. This is not cot. This is cotangent, which makes sense because who does it go with? Tangent. So this is 1 over tangent theta. So if it's the opposite of tangent, it's not O over A, it's adjacent over opposite, A over O. So that's the first new thing that I have taught you. So if we go down here to an actual example, first thing we need to do before we read any of those words over there is this is probably also something new. This angle P, think about like an alligator. Okay, what side does angle P create? Like if you were to looking at my fingertips. What side does angle P create? If you're thinking about that angle. Yeah, it creates this side over here. Do you see that? I'm closing off the triangle. So whatever is across from that angle, if this is capital P, we call this lowercase p, that side. Okay, if this is capital Q, what side is lowercase q? This bottom piece right here, it's across, so this is lowercase q. And then what piece of that right triangle is going to be called lowercase r? The hypotenuse, which is PQ. Did I just confuse you? Okay. So whatever is across from that angle is going to be the lowercase version of that letter. That's what we're going to name it. We're going to need that when we get here, okay, because those are all lowercase letters. So I figured I'd start with that. So the first thing I want to talk about, number one, what is the hypotenuse of this right triangle over here? There's two names for it. What are they? PQ, which is a segment, so put that line on top. I know some of you are having nightmares from geometry right now with the line, the segment on top. And then it also could be called R. What leg is opposite of Q? Two options. What leg is opposite of Q? Okay, it could be little q or PR, segment PR with the line on top. What leg is adjacent to Q? Okay, so Q is here. This is my opposite. That has to be my hypotenuse. The last thing I always label is adjacent because that word confuses me. So what leg is adjacent to angle Q? Lowercase p or QR. Segment QR. Are my O, A, and H going to stay in the same place if I switch to angle P? No. So if I move from here to here, that doesn't look right, but if I move from angle Q to angle P, that's right here, is this still adjacent? No, this is now opposite, and this is adjacent. Is your hypotenuse ever going to change? No, it's always across from the right angle, so those just switch. So what leg is opposite of angle P? Lowercase p or segment QR. And then what leg is adjacent to P? Little q or what? PR. So now we're going to name the trigonometric function, or the trig ratio, because that's a big word, that is represented right here. First thing you need to know is what angle are we looking at in this problem? Angle P. So we just labeled for angle P, so that's awesome. We don't have to change anything. So little p over little r means I'm looking at O over what? H. Okay, let me go. Okay, awesome. Wrapping up the tea. Actually, that's wonderful. Okay, so I was saying we have O over H, which is which trigonometric function? What's O over H? Sine. Good job. Okay, so this is sine of angle P. So we write sine P. What about little q over little r? That is A over H. So what trigonometric function is that? Cosine of P. And then little p over little q is O over A, which is what? Tangent of angle T. Thank you. Does anyone have the last name of Stebbins? Go whenever you'd like. Okay, so O over A is, I can't pay attention. What are we doing? What's O over A? Tangent of P. What is different about number 9, 10, and 11? We're looking at angle Q. So I'm no longer looking at angle P. I'm looking at angle Q. And what am I going to do if I'm now looking at angle Q? Switch my opposite and adjacent. Beautiful. So now this is opposite and this is adjacent. So P over R isn't going to be sine anymore. If you had to guess, what do you think P over R would be? So P is A, right? Over R is hypotenuse. So it's not sine anymore. What is it? It's cosine of Q. So it's switched. Okay, Q over R isn't going to be cosine anymore. What's it going to be? What's Q over R? Opposite over hypotenuse, which is sine of Q. Good job. And then Q over P is O over A. So that's going to be, I can't spell. What's that going to be? Tangent of Q. What's different between these two right here? They're both tangent. What's different about them? They're flipped because we flipped to the other angle, so they have to be flipped. Okay. Last thing I think I might do today is, what do we know about the measure of angle P? So stop thinking about SOHCAHTOA. Go back to your picture. What do you know about the measure of angle P plus the measure of angle Q? It's equal to 90 degrees. Why is it equal to 90 degrees? Because triangles add up to 180, and I already have 90, so I only have 90 left. Now, do you guys also have nightmares from geometry about that stupid degree sign? And like how some teachers took off half a point if you didn't put the degree sign? Did you have those teachers? Okay. We don't work in degrees for very long. We switch to these things called radians, and they have no symbol that you have to remember, so that's good. Okay, but it's a little bit more complicated than degrees. Hopefully it doesn't seem to. Okay, what do you know about sine for angle P and cosine for angle Q? What do you know about them? They are the same, because all you did was switch your O and your A. So if you switch your O and your A, you just have sine and cosine from a different angle. You can also write equal there. And then what about sine of Q and cosine of P? They're also the same. Do you have to remember any of that? No. Why don't you have to remember that? Didn't we get those answers using SOHCAHTOA? So you don't have to remember anything like that. Will it help you be faster? Yes, but do I care about fast right now? No, I care about you getting the right answer. Okay, we'll work on fast as the year goes on. And I just want to look and see what's on the next page. Okay, yeah, we can be done. So you are done for today. I know.